All right, this last problem says that we have a syringe holding a sample of 25 milliliters of argon gas at 22 degrees Celsius. Then we're going to place that syringe in a freezer, and as it cools down, the volume should decrease according to Charles' law. So what will that new volume be? Let's assume that the pressure remains constant. Well, this is a scenario where we have an initial set of conditions and then a final set of conditions. So this is going to be a combined gas law problem. P1 V1 over T1 is equal to P2 V2 over T2. However, pressure remains constant. So P1 is equal to P2, and they simply divide out of the equation. They just disappear. So what we really have is V1 over T1 is equal to V2 over T2. The thing, well, let's see, let's make our variable list. We're going to have V1, whoops, started to write divide by again, V1, T1, V2, and T2. Let's see what numbers we have for each. Our initial volume is 25 milliliters. Our initial temperature is 22 degrees C, but again, we don't stop there. We're going to add 273, which gives us 295 Kelvin. V2 is what we're looking for, and T2 will be negative 18 degrees C. So we'll have to add 273 to that. Let's see, so that's 273 minus 18. Around that 18 to 20, because I can say that 273 minus 20 is 253, but I subtracted 2 too many, so I need to add 2 back. So that's going to be 255 Kelvin. I'm not real good at doing math in my head, so I always have to make approximations and use nice round numbers and then adjust. Okay, now the thing we're looking for is V2. So up here in our equation, V2 is divided by T2. So to get V2 by itself, I need to multiply both sides of this equation by T2, and flipping this around so that I have the unknown on the left-hand side, I've got V2 is equal to V1 times T2 divided by T1. My 8th grade math teacher, I still to this day remember him. His name is Mr. Wilhelm, and I can't even begin to tell you how many problems we did that were just literally rearranging the equations like what we just did and going from up top to down here. And one of the things he just absolutely harped on was when you get one of the unknowns by itself, you always put that on the left-hand side. So I hope I didn't confuse anybody by flipping my left and right-hand sides in that last step. Anyway, if I did confuse you, let's just blame Mr. Wilhelm. But honestly, he was an awesome teacher. Okay, so let's see if we can plug numbers into this equation now. For V1, we have 25, and I think I'm going to have enough room, so I'm going to go ahead and write in my units. That was milliliters. T2 was 255 Kelvin, and then T1 was 295 Kelvin. And notice now in terms of units that kelvins cancel out between the top and the bottom. They are gone. So what we are left with is just units of milliliters. So our final answer will be in milliliters. If we run this through a calculator, we're going to have 25 times 255 divided by 295. And my calculator is telling me that that is 21.6 milliliters for our final answer. Now let's see if that makes sense. As the temperature went down, we found that the volume should decrease from 25 milliliters to 21.6 milliliters. So it did get smaller. So hopefully that all makes sense, and I did all of the calculations correctly there. Anyway, that's it for these 3 example problems. Eat 'em up, cats.